Hello, I'm Mandy Chan, a developer advocate at Google. Today we'll talk about how to build interactive games for the Google Assistant. You will learn what is a conversational action and the interactive canvas API that empowers developers like you to build full-screen gaming experience for smart display and Android devices using JavaScript. Before we dive into the technical how-to, let's see how Google Assistant can help you reach users across the globe by supporting over 19 languages in more than 80 countries. Wherever your user is, Google Assistant can help them get things done on over 1 billion plus devices. You have more ways than ever before to be there for your users. Users are using these smart devices in many different ways. Based on the research done by Adobe, most users are using these devices for music and productivity, like asking for the weather. But there is a large user base of people who are using it for fun and games. 53% of the users use Google Assistant for asking fun questions, 20% for playing games. We launched a smart display in 2019. Over the course of 2019, the percentage of smart homes that include a smart display has increased by 4 times. An increasing number of people are engaging with our smart displays. Now, you may wonder, what are some of the games on Assistant today? The past 2 years, we have seen good traction with voice games on Google Assistant. Developers have crafted great interactive experiences by taking advantage of what the assistant does best: understanding users' voice. These games have been successful at creating an immersive experience in an audio-only environment. Since the popularity of smart displays, developers have also built some visually engaging voice games like these 3 here. Guess the drawing. You can watch hundreds of beautifully hand-drawn animations slowly review pictures and guess the drawing. Trivia Crack. You can answer questions about history, art, entertainment, and science. And the third game, Who Wants to Be a Millionaire? Answer trivia questions correctly to climb the money tree from $500 to $1 million. You can use your lifelines when you get stuck, or 50-50 to eliminate the incorrect answers. Let's watch a video of how each of these games work.
Hey Google, let's play a game.
Let's start.
Give me a hint. Oh, volleyball. Yes!
Welcome to Trivia Crack!
50-50. Concrete?
That's correct!
Welcome, players.
Who is Thomas Paine?
Say a silly word.
Zwinks?
Puzzle of the day.
Well, that was fun.
If you're looking for creative inspiration, I recommend you to try them out. Here's another game that takes advantage of the screen plus voice experience. It leverages the surface to simplify multiplayer experiences. For example, it helps keep track of whose turn it is by showing the user avatar. All of these visual animations are made possible by Interactive Canvas. Interactive Canvas is an API that allows developers to create fluid animations and customize game experiences using technology you are already familiar with, like HTML, CSS, JavaScript, and WebAssembly. Pairing these visual capabilities with Google's natural language understanding and speech recognition, developers can unlock their creativity by building a deeply immersive game with animations and sound. Before we dive into the addition of interactive canvas, here's a diagram of an action with Actions Builder and a web service. Web services can be used to provide dynamic prompts, make API calls, or check your database. When the user talks to the device, "Okay Google, talk to my conversational action," the device sends over the audio with what the user said to the action. The action then processes the request. When returning a prompt, your web service includes data like the Canvas web app URL and other metadata. Once the device receives this, it will initialize your web app. In the web app, the interactive Canvas API is initialized, and then the website is rendered on the device. As users interact with your action, you can update and request data between the server and the client. This is the high level of what is happening. Canvas is currently supported on smart displays and Android phones. So, this means before you send back a Canvas response, check the client's device to see if it supports Canvas. We do this by checking if the device capabilities include interactive Canvas, as shown on the screen. Now, to load up the Canvas web app, you will have to use the new class Canvas provided by the Node.js client library. This class has two properties, URL and data. Keep in mind that the first time you send back a Canvas response, it must have a URL. This tells the device where to fetch the web app. It's important to make sure the URL is HTTPS so it's served up securely. Let's take a look at some actual code on the fulfillment side. In this example, when the user says, "Talk to awesome action," the first webhook call is our welcome intent. Remember, before we send a Canvas response, we should check if this device supports Canvas. To do that, we check com.device.capabilities.includes, passing in interactive Canvas, and make sure it is all uppercase because it's case sensitive. Now that we know the device supports Canvas, let's send back a response. In this case, we are sending back the Welcome to Canvas Workshop prompt. Since this is the first time we load the web app, we must send the URL which tells the device where to fetch the web app. As a side note, you can see we are not sending back any data in this first response because it is not needed. In this example, since this is a subsequent response we send back, we don't need to include the URL as we don't want to reload the web app. However, we are including the data property in order to send the application state to the client. The data property is an object, and you can have as many properties as you need for your application. It's important to know that the Canvas response must be 50 kilobytes or smaller in size. So we just talked about how the server sends back the Canvas response to load up the web app on the device. Now let's look at what happens on the client side after receiving the Canvas response. A web app is a web page that is rendered on the device. It is built using traditional web technology like HTML and JavaScript. When the web app is loaded, it also initializes the Canvas JavaScript library. This is a client-side library that runs on the device, not to be confused with the server-side Node.js client library. The Canvas JavaScript library handles response from the server and also make requests to it. You can also build the web app using some popular JavaScript frameworks like React or libraries such as Pixie.js. We recommend you to build a SPA, single page application, because it can avoid flickering and ensures a seamless UI experience. Here's a basic web app for Canvas. As you can see, this is a standard HTML page which includes the Canvas API provided by Google. One more thing to point out is the line highlighted. This is the code that you write for your client-side application. It is also the main entry point of your web app on the client side. As a part of the web app loading process on the device, interactive canvas library is imported and initialized. After it's been initialized, you will have access to an instance of the interactive canvas, which allows you to handle canvas response by using the onUpdate callback, send requests to the server by using the sendTestQuery method. The interactive canvas instance also allows you to register callbacks by using the ready method. So let's look at some code now. We first define a literal object called callbacks. In this object, there's one important function called onUpdate. It will get triggered every time we receive a canvas response from the server. OnUpdate takes a parameter called data. This data actually comes from the canvas response data property that was sent back from the webhook. After you call ready on the interactive canvas, your web app is initialized and it handles the first canvas response sent from the server. Here's an example inside the onUpdate method. When the client side receives a canvas response from the server, the callback method onUpdate is triggered, and the data property of the canvas response is passed in. In this case, we will look at the scene state property of the data object. Depending on the scene state, in this case, welcome from the canvas response, then we update the UI on the device. So far, we have talked about how to handle canvas response from the server on the client side. What about sending requests from the client to server? This can be done by calling the sendTestQuery method on the interactive canvas object. SendTestQuery takes a string value, which is a phrase that the user would otherwise say to trigger the correct intent. This is a powerful method to communicate with the server, and we will take a look at some code to show you how to do this. Here's an example. We have an image element which is listening to a click event. When this cat image is clicked by a user, it invokes the function called selectCat. The selectCat function will tell the server the user selected a cat by calling sendTestQuery method on the interactive canvas object, passing in the phrase, "I want a cat." This phrase, "I want a cat," is what users would either say or type normally, but with sendTestQuery, we're able to let the server know through code that the user has selected a cat. In addition to sending a training phrase to the server by using sendTestQuery, we can also send additional state to the server using setCanvasState by passing in a JSON object. This is very useful when you want to sync the state of your client web app to the backend fulfillment. In this example, we are sending the additional data, which is the score of 150 by calling setCanvasState. To access the state on the server side, we use com.context.canvas.state. Now that we have talked about what is interactive canvas, how the client and server interact with each other, and how we maintain state between the server and client, let's talk about the design principles when it comes to building games for the Google Assistant. When building an interactive game, you want to make sure it's conversational instead of command-based. Think about the beginning experience of your game. Who are the characters in your game? Engage with your users with back and forth conversations and do not use voice as a controller. It's important to leverage visuals when building games for smart displays. Give your users visual cues. What items on the screen is interactable? Use animation to show them points of interest. In this virtual pet game example, you can clearly see what items are interactable. If you're coming from the voice game role, take advantage of the fact that visuals can be more efficient at showcasing some interactions. Since the smart displays and other Google Home devices are communal, it's important to optimize display and design with a specific viewing distance in mind. Use a minimum font size of 32 points for primary tests like titles and 24 points for secondary tests like descriptions or paragraphs of text. When it comes to local multiplayer games, take advantage of the visuals to indicate whose turn it is. Use different icons for the multiple players. Just like any other kind of actions, remember to handle errors in your game gracefully. One way to do that is making use of explicit audio or visual suggestions if the users are stuck in the game. To further enhance your game, you can leverage SSML and sound library provided by Google. SSML stands for Speech Synthesis Markup Language. If you are a web developer, just like CSS can give style to the text, SSML can give style to the voice by changing the volume, the pitch of the speech, and even adding some pauses between words. It also allows you to add layering of sound to the background. Here's a demo where a developer has used SSML to create a spooky atmosphere for a Halloween-themed action. Let's listen.
Come in. Welcome to the terrifying world of the imagination.
It used the Parallel Media tab, which is a special SSML tab built by Google engineers. It allows developers to layer music with the spoken prompt. You can learn more about how to build fun things with SSML in our docs. In addition to the special SSML tag provided by Google, we also open source thousands of sound clips that you can use them on any platform. You can even search a specific sound you want for your game. There are many different categories of sound as you can see in the image, such as alarms, animals. Take advantage of these audio files to build your next game. Now that you have learned about the design principles of building an interactive game for the Google Assistant, let's explore what game categories developers have been building for. Work games are a great use case for voice. But with Interactive Canvas, developers can create a more immersive experience by adding animations and other visual effects, like this example here. It is a crossword puzzle game which makes great use of Interactive Canvas. Another game type is great for voice and visual effects is multiplayer games. You can leverage the visual by telling the user whose turn it is by using different icons to differentiate between players. Last but not least, persistent games are also a great use case for voice and visual. For example, online multiplayer games can keep track of the highest scores across the community to create a sense of competition. An interactive canvas allows developers to nicely display the score of the top players for things like leaderboards. Now that you have learned about the different possibilities for building games with the Google Assistant, I look forward to seeing how you unlock your creativity and share your games with us. To learn more about how to get started with building games for Google Assistant, check out our documentation. Here's a list of resources and online communities where you can interact with other developers and learn the latest news. Finally, we would love to hear what you think. Share your feedback about this presentation by going to this link. I'm Mandy Chen. Thanks for watching.